Hi, this is an introduction to the Agilent Waveform Generator and Agilent digital storage oscilloscope that you're using in your measurements lab. This is a short presentation on its use, and more details can be found in the manuals for this equipment, as well as we use these over the next several weeks. The best way to learn how to use this equipment is by exploration, and you will have much time to do that over the next several weeks. We're going to make measurements of a sine wave that will take from the waveform generator and input into the oscilloscope, and also a square wave. And then we're going to take those two signals and put them into a voltage divider on a breadboard. And this will give you a good introduction to the use of these two pieces of equipment, which are common in industry throughout the world and are the best equipment Agilent has to offer to this date. So you should be very excited to use this equipment, and it will prepare you well for your professional careers. So let's begin by turning on the waveform generator. So I just turn on the start button, the power button, and you see the waveform generator is powering up. And we get some introductory screen. This has many different waveforms that you can select from. And we use two main waveforms, a sine wave and a square wave, for much of the work that we do. Those are the two waveforms that we use to test many of our prototype systems and compare their performances. So you see we have the screen, and it's still asking us some questions, and we see the initial opening, and it gives us a sine wave frequency of 1 kilohertz with an amplitude of 100 millivolts, 0 volt offset, 0 degrees phase. So you should understand how a sine wave is represented in terms of frequency, amplitude, offset, and phase angle in either degrees or radians. So I would like to change this to a frequency of 100 hertz and an amplitude of 1 volt peak to peak. So what I'll do is I've already selected sine wave, and when I push that, you see I get some parameters. Now I could have gone back, hit waveform, and since sine wave is highlighted, I could have pushed the key parameters, and I would see the 4 parameters that describe a sine wave appear in front of me. Now the frequency I'd like to change from 1 kilohertz to 100 hertz. Many ways to do this. One way is to just input using the number keys 1, 0, 0. And then you'll see under parameters it gives me a choice from microhertz to megahertz, and I will just select hertz. So now I have a 1 hertz frequency sine wave selected. I'll can select under parameters amplitude, and it says 100 millivolts, and I would like 1 volt. So I'm just going to input 1, and then I'll select volt, and the P to P means peak to peak voltage. So that's from the top of the sine wave to the bottom of the sine wave in one cycle. I select peak to peak. My offset is 0 volts, and my phase angle is 0 degrees, and I'll leave it like that because I don't really need to change that at this point, and I'm just interested in outputting a sine wave and seeing how it appears on my oscilloscope. Now what I need to do then is, you see there are many other features here, units, modulate, sweep, burst, system, and we may or may not use these in the course of our studies, and information is available in the help file on the actual generator itself or in the manuals, which are available electronically. In order for this to actually output this signal, I have to push channel, and when I push channel, I see under output, right now it is off, and I'll push that, which means it'll then become on, and you see the channel light lights up, which means now it's outputting a signal. Now here we have two types of output connectors here. One says sync, and the other says output. for this application, we're using the output connector. We're sending our output signal. And you notice I have a T connector here. Now this is called a BNC connector, and these are BNC cables. And BNC stands for something that you can look up if you wish. It's a standard type of cable that we use. It simply attaches to and the male side of it, and this is the female side, it simply plugs in, you line up the pins, and then you simply turn to lock in place. Now the T connector allows us to send this signal to two different locations. Why do I do that? I'm going to send one to the oscilloscope, and you see this cable is connected here to channel 1 of my oscilloscope. And the second then is a BNC cable, and attached to the end of it are what we call, got a little wires here, what we call mini grabbers. And these little mini grabbers are useful to connect to components, but what I've connected them to are simply two hookup wires. And these are not wires that you have to cut and strip. These are already have little prongs at the end for easy insertion into the breadboard, which we'll use later on. So these are very useful connectors, and that's what I have them connected to. So this will go to our device under test, and this will be our input signal to that. So you see I can send the same output to two different locations using this T connector, and that T connector should just stay in place on the function generator, the waveform generator, for all our future applications. So I've set my input, and what I'd like to do now is I'd like to observe this on the oscilloscope. So you can see that, again, one output BNC cable is connected to channel 1 on my oscilloscope. To channel 2 on my oscilloscope, I have another BNC connector, again, with, at the end, two mini grabbers, and attached to the two mini grabbers, two connector wires, again, just for easy connection to my breadboard. And channel 2 will be used to measure the output of my circuit, that which I'm interested in terms of measurement. So channel 1 will show what the input to my device under test is, and channel 2 will show what the output of that device under test is. So now it's time to turn on the oscilloscope. So I hit the on button of the oscilloscope, and some flashing lights, and a screen will appear. And again, many functions available here on the oscilloscope, and we'll explore what we need. And as I said, the best way to understand the oscilloscope is by just exploration, just by probing and trying things out. Now, we only have one of each of these at each of these stations, so please make sure that both people at each station are pushing the buttons and turning the knobs to make this work. Because that's the only way to learn, is to actually use the device. I don't want one person observing and the other person doing. So please, let's take the time for everyone to get proficient with this. Notice it comes up with some questions here. The language is English we'll be using. It asks questions about the oscilloscope or getting started, some help files. We're just going to start right out by looking at what our sine wave is. I'm just going to push this number 1 here to turn the input signal on, and I see that a sine wave appears. Now let's take a look at what these various knobs and buttons do. First look at, we see here number 1, I've turned that input on. If I want to turn that off, I simply press it again once, sometimes twice, and sometimes either. But I've turned that signal off. So now I turn that signal back on, and you see the sine wave appears. The bottom knob will move that sine wave up and down, and I can see how it says channel 1, how it moves it with respect to the, again, vertical axis. The vertical axis is the volt axis. The horizontal axis is the time axis. Oscilloscopes do not generate signals. They measure signals, and they only measure voltages, and they can measure currents by giving a voltage proportional to the current if you have a current probe. But they measure voltages, and the voltages appear on the vertical scale. And we see that on the grid, each division is described up at the top left corner. In this case, it's 500 millivolts per division. And I can change that with this top knob here. And you see what appears now is 1 volt per division, 500 millivolts per division, 200 millivolts per division. You see I've gone off my screen, and you can see how the wave is clipped because at the top and bottom I don't see the full sine wave. So let me go back to 500 millivolts per division and ask the question, am I actually seeing a 1 volt peak-to-peak sine wave? And you see that I am. It's 500 millivolts and 500 millivolts above, and the same below. It is a 1 volt peak-to-peak sine wave. Now, to make, so we have that, and I can move this up and down, and now I have it centered, as you see, at 0 millivolts. Now, the time scale, I can display more of the wave if I wish by going to the horizontal knob, and the horizontal knob will vary the time scale. So right now you see 5 milliseconds per division. So each box horizontally is 5 milliseconds. And you can do some very basic back of the envelope calculation to show that indeed this sine wave is a 100 hertz sine wave. But the oscilloscope will tell us that. But I can change this time scale. As you see here, I've now made the boxes smaller, 2 milliseconds per division, so I see less of the wave, or I make them larger and I see more of the wave, 10 milliseconds per division. It's the same wave. I haven't changed it. I've just changed how I see it. So I can then go back to my 5 millisecond per division. I see enough of the wave. And now to make some measurements on this. First of all, I notice in channel 1, I have some choices here. And if I push this button coupling, it says DC or AC. When we have DC coupling, that means we measure the steady state amplitude as well as the time varying amplitude. If I pick AC, I will only see the time varying amplitude. So in most cases, we pick DC. The impedance is the output impedance of this device. The input impedance of this device. And we have two choices here, 1 mega ohm or 50 ohms. Ideally, a measuring device should have a very high input impedance so it disturbs what it is measuring as little as possible. So we pick the highest input impedance. Bandwidth limit, we don't need to select that. Fine or invert are simply adjustments that we can make, and you can see what that entails. Under probe, if we push probe, you see units, volts. Now the probe, several probes are available from Agilent that actually come with the oscilloscope, and that simply means that there's an amplification factor between the probe tip and the oscilloscope. It could be 10 to 1 or more. Here it's 1 to 1, meaning the probe measures what the oscilloscope will see, and it's the same. Skew, probe check, or other things that we can, again, investigate. Let's make some measurements here now. So I can go and just go to my, you can see how this is laid out. Here you see horizontal, and that's the time scale. Down here we vary the vertical scale, the voltage. Triggering simply tells the oscilloscope to make a measurement and when to start making that measurement.